Greetings to you all. In this session, we are going to see about the applications of operational amplifiers. I am Uma Maheswari, working as Assistant Professor in the Department of EEE, Kamaraj College of Engineering and Technology. Before entering into the topic, let me highlight what is operational amplifier and its features. Operational amplifiers, in short, we can call it as op-amp, that is play a vital role in semiconductor industries as it is a very fundamental yet powerful component in analog electronics. It is one of the most vital component in analog electronics, which is meant for designing the circuit for amplification, filtering, mathematical operations such as addition, subtraction, differentiation, integrations, and for voltage regulation. And we can describe operational amplifier as a high gain electronic voltage amplifier with the differential inputs and one single output. So the characteristics of ideal operational amplifier is it has input impedance of infinite value, which means it does not draw any current at input terminals. And the output impedance is 0, which means the voltage drop across the output terminal is 0. And the bandwidth is infinite, which means we can work with wider range of frequency signals. And common mode rejection ratio is infinite, which means the common signals like noise signals or interference signals at the output terminals are nullified each other, and hence it ensures the accurate measurement. And the open loop gain is infinite. So this is about the characteristics for ideal operational amplifiers. The values lies in either infinite or 0, but in practical cases whose values are a finite number. And this is about the symbolic representation of operational amplifiers. It is represented in triangular form. The plus sign which indicates the non-inverting input and minus sign which indicates the inverting input. And for excitation of operational amplifier, we have to supply the power supply with positive and negative, and we will receive one output. So this is about the symbolic representation of operational amplifiers, and this is the pinout of operational amplifiers. So IC 741 is one of the example for operational amplifiers. It has 8 pins. Pin number 1 and 5 is meant for offset null, pin number 2 inverting input, pin number 3 we will give the non-inverting input, and power supply which is given at the terminal 7 and 4, and we will receive the output from pin number 6, and pin number 8 there is no connections. Sometimes even we are not applying any input, there is maybe a voltage will be measured at the output terminal. So generally we can call it as offset voltage. This offset voltage which cause erroneous reading, that can be nullified with the help of giving the counter voltage at the offset null. And one more thing we have to note down here is reference point. So the reference point actually is given to inform the user about the starting pin point of our IC. So if there is no marking in the reference point, then it may create a confusion for the end user regarding the what is the starting number of a IC. So the reference point may be represented in IC either in the form of a slot opening or it's a small dot in the pin number 1. So this is for informing the user regarding the reference point. And the operational amplifiers are operated in 2 modes. One is open loop mode and another one is closed loop mode. In open loop mode, there is no feedback connection between the output and input. Generally the comparator circuit will operated in open loop mode, we will see later. And in closed loop mode, which uses the feedback, which means part of output is taken from output and it is fed to the input terminal. So that is called the feedback. So that is to control the gain or to control the functionality of a circuit designed. And in the feedback also we have configured in terms of negative feedback as well as positive feedback. If the part of output is taken and is a feed to the negative terminal, then we can call it as negative feedback configuration. Whereas a part of output is taken and it is feed to the positive input terminal, then we can call it as positive feedback configuration. Generally in control and automation, negative feedback configuration is preferred as it ensures the stability of a system. So this is about the diagrammatic representation of open loop system. See here, input, there is no connection between the output and input, whereas in the feedback configurations or closed loop configurations, we are taking the part of output and feed to the input terminal. Here we are giving the input to the negative terminal. So, this configuration is negative feedback closed loop configurations. And for designing the circuit which utilizes the operational amplifiers, we have to follow two golden rules. Rule number 1 is, for an ideal operational amplifier with the negative feedback configurations, the voltage difference between the inverting terminal and non-inverting terminal is 0. And rule number 2, the ideal operational amplifiers which does not draw any current, which means it draws 0 current at both the terminals. And coming back to the topic applications, the operational amplifiers can be used as an inverting amplifier, non-inverting amplifier, voltage follower, summing amplifier, differential amplifier, integrator, differentiator, and so on. An inverting amplifier, the name itself, it says it amplify the input signal, it boosts up the magnitude of the input signal, but the phase relationship between the input and output signal is 180 degree. So, this is about the inverting amplifier, where in case of non-inverting amplifier, it also amplifies the input signal, but there is no phase difference between the input and output, that is both the inputs and outputs are in phase. And the voltage follower, which means the name itself, it says the output voltage which follows the input voltage, which means the gain is unity, and actually it is used as a buffer circuit or impedance matching circuits. And summing amplifier, sometimes we need to add 2 or more inputs together to get a meaningful data. So, for that time we go with summing amplifiers. And differential amplifiers, which will find the difference between 2 signals, and for mathematical operation like integration and differentiation, that can be done with the help of integrator and differentiator. Let us start with inverting amplifier. So, the inverting amplifier, already I told, it uses the closed loop configuration, in particular it uses the negative feedback configurations, where we are giving the input to the inverting terminal and non-inverting terminal is grounded. And this amplifier not only amplifies the input signal, but also create a phase change. Regarding the circuit diagram, so this is the operational amplifier with input is given to the negative terminal through the resistor Ri, and the non-inverting terminal is grounded, and part of output is taken and is feed to the inverting terminal through the resistor, feedback resistor Rf. So, this is the circuit diagram for inverting amplifier. So, for deriving the output voltage or gain factor, we have to utilize the golden rules of operational amplifiers and Kirchhoff's current law. So, let us start with the golden rule of operational amplifiers. So, according to the operational amplifier rule, the current drawn by the operational amplifier is 0. So, the current flow towards the operational amplifier is here also 0 and here also 0. So, no current will flow towards the input terminals of operational amplifiers. And next we have to apply the another one rule, that is the current flow towards the node and the current leaving the node is equal to 0. So, as per the rule I am going to write the equations. So, the current here VA, here VI. So, the potential difference VA minus VI divided by RI. So, VA minus VI divided by RI, that is the current marching towards the node point A, plus the current leaving the node, that is represented as VA minus V naught divided by RF equal to 0. So, this is V naught equal to 0. So, by applying the Kirchhoff current law, we are writing the equations. Now, we are going to apply the golden rule of operational amplifier, that is the potential difference across the operational amplifier is 0. So, look at here, here the plus terminal is grounded, which means the potential is 0. Then the potential at the point VA is also equal to 0 by applying the rules of operational amplifiers. So, one of the terminal is grounded, so the potential here is 0. So, that is equal to the node A. So, VA is also 0. So, the equation will be changed to by applying the VA value 0. So, this equation number 1 can be rewritten as minus VI divided by RI minus V naught divided by RF equal to 0. So, next VI divided by RI equal to V naught divided by RF. So, I want to find V naught. So, V naught which is equal to minus VI into RF divided by RI. So, this is the output voltage equation for inverting amplifier. So, from that we can refer that output voltage is the inversion of input voltage with the gain factor RF by RI. So, it can be again V naught written as V naught which is equal to minus VI into A, where A is gain, which is equal to RF divided by RI. So, once we know the value of a gain, we can design the inverting amplifier. And applications of inverting amplifier. So, the inverting amplifier not only meant for amplification purpose, it was meant for phase shifter, voltage adder or differentiator, integrator, subtractor or filters. So, in case of phase shifter, so this is the electronic circuit, one of the electronic circuits used to shift the phase of the signal without changing the magnitude of input signal. So, whatever the input signal is given, that has to be produced in the output signal, but there is a phase shift of 180 degree. So, that is the phase shifter. So, by using the inverting amplifier, we can design the phase shifter. So, this is the inverting amplifier. We are given the input to the negative terminal and the positive terminal is grounded and part of output is taken and it is fed to the negative input terminal. So, this is the waveform, input output waveform. So, here I am giving the input of AC sinusoidal waveform of magnitude plus 100 for the positive half cycle and minus 100 for the negative half cycles. But in the output there is a phase shift of 180 degree. So, there is no change in magnitude. Here also the output is around 100 and for negative half cycle that is minus 100. So, there is no change in magnitude, but there is a change in phase of 180 degree. So, this can be possible with the help of a inverting amplifier. Since we know that the output voltage for the inverting amplifier V naught which is equal to RF into RI into given input voltage. So, our constraint is for phase shifter, our constraint is output should be equal to V naught should be equal to minus Vi. RF divided by RI is 1, then the V naught which is equal to minus Vi, this case will be satisfied. So, A should be, that is RF by RI should be 1. If RF which is equal to RI, then only the inverting amplifier can be used as a phase shifter. So, look at here. So, RF is also chosen as 5 kilo ohm and RI which is also chosen as 5 kilo ohm. So, it will meet the criteria for the gain factor value 1. So, it can be used as a phase shifter. And next one, applications of inverting amplifier is summing amplifiers. So, here we have to add 2 or more signals. So, in previous case we are giving only one input V1, but here we are going to give a 2 or more signals and the output is proportional to some of the input voltages of V1, V2, V3 and but output is in inverted manner. So, generally it is used in audio mixing or signal processing unit or data acquisition systems, and this is about the circuit diagram. Inverting amplifier, instead of giving one input, we are giving 3 inputs V1, V2, V3 through respective resistors R1, R2, R3. The same thing, the same law, Kirchhoff current law and the golden rules of operational amplifiers has to be used for determining the output voltage. The current drawn by the operational amplifier at the input terminal 0. So, this is value would be 0. The current flow towards the operational amplifier is 0, but at the node here the current flowing towards the V1, V2, V3 are getting summed up, that is marching towards the node, and IF current is leaving the node. So, by using the Kirchhoff current law nodal equations, we are going to write the equations, and again we have to use the operational amplifier's second golden rule, voltage across the operational amplifier is 0. So, by the way we are going to find the gain factor as well as the output voltage equations. By applying the KCL law, I am writing the equation, sum of the current entering the node and leaving the node is equal to 0. So, by applying this law I am writing the equations. Okay, the plus terminal is grounded and hence the voltage at the point VA is also 0. I am substituting the VA value is 0. So, the equations can be changed to minus V1 by R1 minus V2 by R2 minus V3 by R3 equal to V0 by RF. I am taking minus sign as common. So, V1 by R1 plus V2 by R2 plus V3 by R3 equal to V0 by RF. Now, I am substituting another one case, that is if R1 which is equal to R2 which is equal to R3, let us take it as R, then this equation can be changed as V0 which is equal to minus of RF divided by R into summation of V1 plus V2 plus V3. So, I am giving one substitution R1, R2, R3 which is equal to R, and hence the V0 which is equal to minus RF divided by R into V1 plus V2 plus V3. If I am going to use it as an adder, then another one substitutions will be given. If RF which is equal to R, then the equations will be changed to V0 which is equal to minus V1 plus V2 plus V3, that is it will act as a adder, but the output is in the form of inversion. So, likewise summing inverting amplifier can be configured as a adder without amplification, just by choosing the feedback resistors and the input resistors, both the values are equal, we make the amplifier circuit to be a adder circuit. If suppose I want to design a averager unit, then I have to choose the appropriate values of feedback resistance. So, AR which is equal to N into RF, where N which resembles the number of inputs. So, R which is equal to 3F, then the equations will be changed. This equation will be changed to V0 which is equal to RF as written as RF, and instead of R I am writing 3 RF. Since I am giving 3 inputs, so I have chosen the R value as 3 RF. So, V1 plus V2 plus V3. So, here RF cancel. So, the V0 equations will be V1 plus V2 plus V3 divided by 3. So, likewise we can make the circuit either phase shifter or adder circuit or a averager unit. So, by selecting the appropriate resistor values and components, we can design the inverting amplifier as a phase shifter or adder or averager unit. Thank you all.